Okay, so I'm going to do a problem similar to number 115, only this time I'm going to change it up a little bit so you can still work the problem. I'm going to use acetic acid instead of barbiturate, whatever that acid is. I've given the Ka here. I'm keeping the concentrations the same just to make it easy. So before any reaction has taken place, all I have to worry about is taking acetic acid and disassociating it in an equilibrium into these two. So this is going to start out, and that's rice. And so this is 0.100, 0 and 0, minus x plus x plus x, 0.100 minus x, x and x, 1.8 times 10 to the negative fifth. It's going to equal x squared over 0.100 minus x. If you like, you can go through the quadratic formula and figure out if x makes any difference. I'm just going to assume that it does not. And so this would be 1.8 times 10 to the negative 6 equals x squared. So 1.8 second, I need to take the square root of it. So second square root, 1.8 second EE negative 6 equals, and so x equals 0.00134 molar. So that is the acetate concentration and the hydrogen ion concentration, and it asked me for the pH. So the pH is going to equal negative log of 0.00134. And so negative log second answer, I get that the pH is equal to 2 point, and I have 3 significant figures, so I need 3 decimal places. 2872. Okay, you know how to do that. That's not new. The next part is new. So part B. Part B, I've added some sodium hydroxide. So I'm going to add 20 milliliters of 0.100 molar NaOH. So I have NaOH plus CH3COOH. It's going to give me CH3COO minus. I'm going to have some sodium ions left over, but I don't care because they're not going to do anything to the pH. And all of the hydroxides will react with hydrogen ions to give me water. I don't care about the water either, but I do care about these two. When I do this kind of reaction, I have to do it in moles. So I'm going to convert these to liters. So this is going to be 0.020 liters times 0.100 molar, and that tells me how many moles I have. So 0.02 times 0.1 equals, surprisingly enough, 2.00 times 10 to the negative third moles. That's how many moles of NaOH I have, or hydroxide ions. I have for my acetic acid, I have 40 milliliters. So it's going to be 0.0400 liters times 0.100. So the moles I have of acetate ions is going to be 4.00 times 10 to the negative third moles. Now, if I have some of this and some of this, one of them is going to be a limiting reactant. I have more moles of acetic acid, so therefore sodium hydroxide is limiting. I will lose all of this. So this is initial. This is my change. I have to do the same change to acetic acid. So I'm going to lose 2.00 times 10 to the negative third moles here. And if I lose it here and here, I'm going to gain it over here. So I'm going to gain 2.00 times 10 to the negative third moles here. That gives me at equilibrium 0 sodium hydroxide left. Now I have 2.00 times 10 to the negative third moles of acetic acid left. And I have 2.00 times 10 to the negative third moles of acetate left. So now I'm in a buffer. So I have, in fact, this is probably the optimal point in my buffer system. But I do have to worry about my new volume because these are moles, not molarities. So I had 40 milliliters and I added 20 milliliters. So my new volume is 60 milliliters. So I would have to divide this by 0.0600 liters. Divide here by 0.0600 liters. And so that divided by 0.06 gives me my new molarity here is 0.033 molar. 0.033 molar. And so now I'm doing my ice table again. And I'm going to get hydrogen ions out here this time because I'm going to lose X here. I'll gain X here and I'll gain X here. And that gives me 0.0333 molar plus X, 0.0330 plus X, and plus X. So Ka is going to equal 1.8 times 10 to the negative fifth, which is going to equal this should be minus X. 0.333 plus X times X divided by 0.333 minus X. Now, if you want to go through the quadratic, have at it. You probably should. I'm not going to. So I'm going to ignore X here and ignore X here. Then these two cancel out. So X is going to equal 1.8 times 10 to the negative fifth. So that's my hydrogen ion concentration. If I take the negative log of that, negative log of 1.8 second E negative 5 equals 4.74 is my pH. Okay, so you can see these problems get fairly long fairly quickly. Now I'm going to have 39 milliliters. So let me get a new sheet of paper. So I still have the same reaction, NaOH plus CH3COOH, CH3COO minus, plus, again, I don't care about the sodium ions, I don't care about the water ions, or molecules. This is the things I'm interested in because I need these two numbers to go forward. So now we're adding 39 milliliters of NaOH. And we have to again figure out how many moles we have. So 0.039 liters times 0.100. I get 0.0039. And we've already calculated this one out as 0.0040. And these are again moles. And we are not carrying anything forward. We're just considering it in one fell swoop. So I would have initially 0 of this, and those don't matter. So again, this number is smaller than this one, so I'm going to lose all of this and have 0 moles of NaOH left over. I'm going to lose 39 of those. I have 0.0001 moles of this. I'm going to gain it over here. And then that'll give me 0.0039 moles of that. Now, I've added 39 milliliters to 40 milliliters. So I have 79 milliliters, which is 0.079 liters. I have to convert these back to molarity. So I'm going to divide both of these by that volume. So I've got that one divided by 0.079. This is 494 molar. Now 0.0001 divided by 0.079 is going to be 0.01227 molar here. Now, I still have my acetic acid, my acetate, and my hydrogen ions. So, since I don't have any hydrogen ions, or really very, very small, I'm going to lose X here, I'll gain it here, and I'll gain it here. And this will be 0, well, I'm just going to do 1.27 times 10 to the negative third minus X, 4.94 times 10 to the minus 2 plus X, and then X. And this is a case where I would go ahead and do the quadratic formula. So I'm going to leave it at this point. I think you can get it. I'll give you the answer. Well, I can't because it's a different acid. But if you can't figure it out from here, tell me how far you're getting. I can always give you the answer. Okay? Okay, I'm going to work on grading quizzes. Thanks.